what kind of shape is this? Okay, so let's quickly go through. I've seen the right algebra on a lot of your pages so far, but just in case you're struggling a little bit with it, let's give it a go. Okay? So this is the ratio, it's equal to a half. Yeah. And I think before, because we're using all of the same features, okay, the left and right hand side are going to come up looking quite similar, at least for a little while. Okay. So I think we end up having, let's see, square root of x squared plus y squared plus 2y plus 1 is equal to, sorry, that's terrible, half absolute value. Does that sound about right? Yep, good. Okay. Now, you guys know from doing locus before that one of the classic beginner's errors is to square everything and to forget any constants that are there. Okay, classic error. So don't do it. You may even like to put that half over the other side because then you'll be dealing with whole numbers. Okay. Actually, I will get to fractions later on, but it's sort of easier to work with big numbers. So I'm going to get 4 x squared plus y squared plus 2y plus 1, y squared plus 8y plus 16. Okay. By the way, I did mention before to most of you, not the 3 of you, that the only rule in my class is the human rule, right? Treat me like a human being, I'll treat you like one too. One of those things is that to err is human. So I will make mistakes, I can guarantee it. This isn't one of them, but I'm just preempting myself, okay? So catch him out. I had a lecturer actually who would, he had a tax, he had an error tax. So anyone who could find an error, he'd pay him 20 cents. That was a while ago. I should probably bump that up, like inflation and all that, but I'll try and work out what it'll be. Anyway. So let's see, what are we going to get? 4x squared plus 4y squared plus 8y, excuse me, plus 4. Excuse me. So what are we going to get now? 8y's cancel. I'm going to bring the constants all over on the right-hand side. If you haven't done that already, that's okay. But for reasons that will become clear in a second, it's going to be simpler for us. So I'm going to get 4 from 16 is 12. 1y squared over here, 3 over here. So a lot of you probably have stopped there, and that's fine, okay? Excuse me. However, if you have just stopped there, I'd like you to write one extra line, which is to divide everything through by 12. Okay, so this is what I'm going to get. X squared on 3, y squared on 4 equals 1. Okay, now, some of you have already drawn this. That's actually, how many of you have drawn it already? Hands up straight, so I can see. Oh, not that many of you. Okay, that's fine. Hands up. What is this thing, is my question. Okay. What kind of shape is it? Now, there's a short answer, and there's an answer which takes a little more thinking, okay? So let me consider what would happen, for instance, if I change that to a 4, okay? What kind of shape is this? You know it's a circle because if you were to multiply through and not have it with weirder looking fractions, you'd have x squared plus y squared equals 4, okay? So it's almost a unit circle, it's twice the radius, so 4 times the area and so on, okay? So that's a circle. But the fact that this is not a 4, but it's a 3, okay, means that when you're adjusting one and the other by different quantities, okay, you're kind of squeezing and squashing, but not in the same proportions, okay? So what are the intercepts for this thing? And that's why you'll see it's useful to have the 1 over here and all the fractions over here. When you work out the intercepts, okay, for instance, let's work out the x-intercepts. How do we do that? Y equals 0. So that's going to lead me to x squared on 3 equals 1. Okay? So x squared equals 3, so you got plus or minus about 1.7. Yeah, which is important because we're going to graph this in a second. Do the same thing to get your y-intercepts. And you can probably anticipate what's going to happen, right? Y squared on 4 is 1. Okay? So let's skip a step because I think you can handle that. Okay? So plus or minus 2. 1.7, 2. Now you're getting a sense for the scale. Okay? So what kind of thing is this? It's like a circle, but it's squashed. How squashed is it? That's how wide it is. And it's just a smidge taller than it is wide. I was doing so well. And then I just lost point. Anyway. Okay, so there you go. It's an ellipse. Now, I'm pretty much going to stop there, but I'm going to put some labels onto this, okay, because we need to be able to describe this in some way. Okay. Firstly, this is where we ended. When did we start again? What was the beginning of this thing? We started with a focus, and a directrix, right? So now, hold on, have a look at this thing. Where are the focus and the directrix? I've probably given myself just enough space down here. The directrix is at -4, so I'm down here. Okay, where's the focus? So it's kind of, well, it's halfway between the origin and that lowest point, isn't it? There's S, okay? So there's the focus, there's the directrix, but you might notice, because of the symmetry of this shape has a symmetry that the parabola, which I just wiped off, doesn't have, okay? It's got this kind of reflectional symmetry. So this is not the only focus. This is not the only directrix. Where else could I put them? I could reflect across the x-axis, couldn't it? So I could put S there, it would be what? 0, 1, okay? And I'd have the focus there, yep, and the directrix at y equals +4, okay? So when we're looking at questions to do with ellipses, okay, we're no longer talking about a focus and a directrix. We're talking about foci and directrices, okay? Because it's not like one is more the focus than the other, or one directrix is more important. They're exactly equal, okay? So in the questions, you'll be asked to find out both.